Two ships set sail at the same time. So that's A, which is going due east or and at 15 kilometers an hour, and B, which is going south at 30 kilometers an hour. So they're both moving away. A is moving towards B, but then B is also moving downwards at the same time. Ship A is traveling east at 15 kilometers an hour, and ship B is traveling due south 30 kilometers an hour. Find the distance between the two ships 30 minutes after they set sail. Give your answer in kilometers, correct nearest decimal place. All right, the first thing I'm going to do is I'm going to work on A. So it was originally 90 kilometers, okay? And this red distance here from here to here, I'm going to work on this distance. It was 90, and then A moves forward. So A moves forward a certain degree. And what I'm after now is this new red distance I have here, this distance here. So it's going to be 90, take away. It's 15 kilometers an hour, so distance equals speed multiplied by time. So it's going to be 15 kilometers an hour multiplied by half an hour, which is going to be 7.5. 90 minus 7.5 is 82.5. Okay, now the next thing we're going to look at is how far did B travel? Well, B traveled southwards, like so. So B is going to be 30 kilometers an hour multiplied by a half, which is going to be 15 kilometers. So essentially what we have is a triangle that is 82.5 across and 15 down. And we're asked to find the distance between the two ships, which I can use as this black line here. Is that okay, everybody? Now we're going to use Pythagoras' theorem for this. So it's going to be d squared equals 82.5 squared plus 15 squared. Okay, throw that into the calculator. And you're going to get 70 d squared equals 7031.25. We're going to square root that. And we square root our answer. We're going to get to two decimal places. We're going to get 83.85. Okay, so the distance has increased between the two objects. Okay, and that's in kilometers. Now, next question, which no doubt will be a step up. Okay, and that went for 10 marks. That went for 15 marks right there. Okay. Now, question B. T is the time in hours. Oh, sorry. I have to do part B. T is the time in hours after ship sets sail. Show that the distance between the ships at time t can be given by this function here. Now remember, you can use this answer to answer part C straight away because it's a proof question. So you can use part B, this equation, to answer part C. But in the meantime, I'm going to figure out how they got this equation. Now, we're going to redraw that diagram from the first one. Okay, now here's what I'm looking at. It was 80 kilometers. Okay, sorry, it was 90 kilometers, wasn't it? Oh, sorry, it was 90 kilometers, so it got closer because it's now only a distance of 83.85. So it was 90 kilometers. And what happens is every hour we're going 15 kilometers closer to where B starts. So this distance is going to go downwards. But it's going to be 90 minus 15t. 90 take away the speed multiplied by the time it's traveled. That's what we did in question 1. We got 90 and we took away 7.5, the distance that it covered in a half an hour. So we're still doing 90 take away 15 times t. Now the next thing to look at as well is the fact that B is going southwards at 30 kilometers an hour. So it's going to be 30 kilometers an hour multiplied by the amount of hours it's spending, it's traveling for. Okay, and what we're looking for is the distance between the two ships, which is D. So here's what we're going to set up. We're going to set up d squared equals 90 minus 15t squared plus 30t to be squared. Now we're going to multiply all this out. So it's going to be 90 minus 15t by another 90 minus 15t. and that's going to be 30t multiplied by another 30t. Okay, and let's see what happens here. 90 times 90 is 8,100. 90 times 15 is 1,350 t. And then minus another 1,350 t for that one as well. And 15t by 15t is 225 t squared. That's 15. And then finally, 30 multiplied by 30 is 900 t squared. And this is all d squared, remember? Now t squared on its own is going to be 225 plus 900, which is going to be 1125 t squared. We're going to get our 2,700 t in the middle, and then we're going to get our 8,100 at the end. Now, we don't want d squared. What we want is d on its own. So you can see that we have all the numbers we're looking for. Now we're going to square root it. So an example is if you had x squared equals 81, you could say that x equals the square root of 81, or 81 to the power of a half. They all mean the same thing. Now, instead of 81, what we have is all of this combined. So this means that d is going to be all of this. It can be the square root of it, or it can be the to the power of a half. Okay. Please remember, power of a half is just the same thing as a square root sign. They mean the same thing. Okay. So that's what we have there. Now that we've got that done, we're going to go back up and see what the crack is with this one here. Use calculus to find the value of t for when the ships are close to each other. So you're looking for what's called the minimum. Minimum. Okay, and find the distance between the ships for your value of t. Now, I'm just going to get this equation from the last question. This equation here. Just going to copy and paste it across. Okay, so this is what we're working with. So we're going to try and differentiate this. Okay. Now, let's have a look at how we differentiate something like this. Okay. So first of all, if we're differentiating fx, the first derivative will be f dash x. So this means the first derivative is s dash t. Secondly, if I ask you to differentiate something like this, I'll give you an example. If I ask you to differentiate 3x squared minus 5x to the power of a half, or to the power of 5 even, right? So how I do this is I bring the 5 to the front and take 1 away from it. 5 to the front, and then keep the chain the same. Take 1 away from the power, and then differentiate what's inside. And when you differentiate what's inside, what you're going to get is you're going to get 6x minus 5, because you're bringing the 2 to the front and then differentiating the 5. Now, this is no different from what I just did there a second ago. What we're going to do is we're going to get the half, and we're going to take it to the front. So it's going to be a half. The chain remains unbroken, like so. And then we're going to take 1 away from the power. So a half take away 1 is minus a half. Okay. And this, so we're looking for the derivative of where it's at its minimum. Okay, it's at its minimum. Now the next thing we got to figure out is we have to differentiate what's in the bracket, which is going to be t squared. So 2 multiplied by 1,125 is 2,250 t. And then that has a t there as well, doesn't it? I forgot the t on the 2,700. So just minus 2,700. Now, for a turning point like a minimum, the first derivative equals 0. So this whole thing, which is going to be 1 over 2. Now, if I had x to the power of minus a half, x to the power of minus a half is basically 1 over x to the power of a half. Same thing as x to the minus 3 is 1 over x3. So this whole thing to the power of a half, power of minus a half, is going to put it on the bottom. Okay, so it's going to put the whole thing on the bottom. This whole part here is going to be underneath, so it's going to be all divided by 1125 t squared minus 2700 t plus 8100, and that's going to be power of plus a half now because it ended up on the bottom. And then we still have the 2250 minus 2700 on top. There's a t there as well. Now remember, the first derivative equals 0. So when we cross multiply up the denominator, it's getting multiplied by 0, therefore it disappears. So what we're going to be left with is 2250 t minus 2700 equals 0. Then what we're going to have here is t equals 2700 when we bring it across, and the 2250 underneath, then put it underneath. T equals 2700 divided by 2250, which is 1.2 hours. Okay. Find the value of t, done. But I'm also going to need to find the distance. Okay. And the distance is given to me by this equation here. So I'm going to go all the way down below here. And you got to show workings for this. Anywhere I see t, I'm going to replace it with 1.2. So it's going to be 1125 by 1.2 squared. Okay, then it's going to be minus 2700 times 1.2 plus 8100, and that's all to the power of a half. Now, we're going to throw all this into the calculator. Okay, so start off with brackets, and then we're going to have 1125 multiplied by 1.2 squared minus 2700 times 1.2 plus 8100, close bracket, to the power of a half, 1 over 2. Press the equal sign and we get 80.49 or 80.5 correct to one decimal place. So that is your closest distance together.